Good morning everyone! I'm Sir Marlon Revidizo and welcome to our Grade 9 Math. Today, we are going to study about Pythagorean Theorem.
Our objectives are prove Pythagorean Theorem and solve problems involving Pythagorean Theorem.
Before we continue, let's have some trivia about this theorem.
Pythagorean Theorem was named after Greek mathematician Pythagoras. He was born on 570 BC in Greek Isle of Samos, and one of his teachers was Thales. Pythagorean theorem is used to solve for the lengths of the sides of a right triangle. When do we say that a right triangle is right triangle? Correct, if it has 90 degrees angle or one right angle, and the other two angles are acute angles. What do we call the two shorter sides of a right triangle? Correct, side A and side B are what we call the legs. And how about the longest side? You're right. The longest side is what we call the hypotenuse. The Pythagorean theorem states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. If A and B are the lengths of our legs and C is the hypotenuse, we will have A squared plus B squared equals C squared. Let's consider this triangle with sides 3, 4, and 5. Using 3 as A, that means A squared is equal to 9, and the geometric equivalent of squaring a number is the square shape, and we have 9 square units. And for B, which is 4, we have 16 square units. And for the hypotenuse, which is 5, we will have 25 square units. On the arithmetic side, if we add amounts of areas of A squared and B squared, it will be equal to 25, and rearranging the unit sequence, the area of squares formed by two legs is equal to the area of squares formed by the hypotenuse.
Now, let's have a drill.
Tell whether the given lengths are sides of a right triangle. Number 1, 3, 5, and 8. Number 2, 9, 40, and 41. Number 3, 5, 10, 15. Number 4, 12, 16, 20. And number 5, 2, square root of 3, and square root of 7.
This time, let us solve the length of the third side of the following right triangles.
If the length of two legs are 8 and 6, find the length of the hypotenuse. Using the Pythagorean theorem, A squared plus B squared equals C squared, first, identify the value of A, B, and C. Let A is equals to 8, B is equal to 6, and we will be solving for C. And now, we will substitute 8 to A and 6 to B. 8 squared is equals to 64 and 6 squared equals to 36. And 64 plus 36 equals to 100. We can also write it as c squared is equals to 100. Then get the square root of both sides of the equation, and the square root of 100 is 10. Therefore, the length of our hypotenuse is 10. Let us have another example. What if the length of the leg of a right triangle is unknown? Given a right triangle with a hypotenuse of 13 and one leg is 12, we will solve for the length of the other leg. We will use 12 as A and 13 as C to find the value of B. Now, let us substitute A and C. Then, simplify. And the length of the other leg is 5. Now, let us solve problem involving Pythagorean theorem in real life. A 10-foot ladder is leaning against the wall of the building. If the foot of the ladder is placed 6 feet away from the base of the building, how high up the wall does the ladder reach? In this example, 10 is the length of our ladder or our hypotenuse. Then 6 feet is the length of one of our legs. Therefore, we are going to look for the other leg. Since this figure has right angle, we have a right triangle. To solve this problem, let's assign the value of A, B, and C. So here, A is equals to 6, C is equal to 10, and we're going to look for the value of B. Now, using the Pythagorean theorem, let's substitute the given values. So we will have 6 squared plus B squared is equals to 10 squared. And simplifying 6 squared and 10 squared, we will have 36 and 100. And by addition property of equality, B squared is equals to 64. So getting the square root of both sides, we will have B is equals to 8. Therefore, the top of the ladder is 8 feet on the wall.
And now, try this one. And that is our lesson for today. I hope you learned something. Happy learning!